This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to simplify radical expressions, and we're going to focus on addition and subtraction. So in our first section, we're going to review square roots. In our second section, we're going to go over some examples that are at the easy level. And then in our third section, we're going to talk about some difficult level examples. All right, let's get started. All right, so let's talk about what square roots are. Well, as just a review, let's say we take the square root of 100. Well, the square root of 100 is 10. Why is that? That's because 10 squared is 100. You can see that the squaring, square rooting, they're opposite each other. So one checks the other. Okay, so let's try another one. How about we take the square root of 81? Well, the square root of 81 is 9, and the reason is 9 squared is 81. See, square, square root, they sound the same. They're inverse functions, so one checks the other. All right, so that should be a quick review of square roots. Let's put it to some use. So let's take a look at some beginner level problems. These problems are beginner because all you need to know how to do these problems is to add like terms. Now let's think back when we had algebra and we took like 2x plus x. If you take 2x plus x, well, the answer is 3x. Pretty simple. You could even take example with, like, let's say pencils. If you had 8 pencils, take away 2 pencils, well, you're going to have 6 pencils left. So when you're dealing with radicals, you could only add or subtract like terms. Okay, so in this case, you can see I've got radical 2 and radical 2. Yep, I can combine them. They're the same radical. They're like radicals. So when I combine them, I'm going to combine their coefficients. In other words, their numbers in front. So 5 plus 3, I really have 8 radical 2's. I have 5 there, 3 there. There's a total of 8. All right, let's take a look over here. So I have a square root of 3's here. I have some square root of 3's here. I've got some square root of 3's here. I've got 7 of them here, and I'm subtracting 10 of them there. So if I take 7 minus 10, that's negative 3 radical 3. Okay, so it's just like combining like terms in regular algebra. All right, let's get to some more difficult problems. So let's take a look at these two more difficult problems. Now, what makes them difficult? Well, they look like they can be combined. So if you watched that last section, we found that these radicals have to be exactly the same for us to be able to combine them. And in this case, it's addition. All right, so right now I can't do anything. However, what I can do is I could simplify these radicals. Well, can't simplify this one. That's a prime number, and it cannot be simplified. But let's take a look at the others. Like, for instance, what's 45? Well, 45 is really 5 times 9. Let's see. What's 20? It's really 5 times 4. I didn't break this up as 3 times 3 because in this case, I think you could see what's happening here. I think when you take a look at that 9, you could see that I could take the square root of it. When you see that, you see the 4 there, I can take the square root of it. So what's the square root of 9? It's 3. So I'm going to bring a 3 on the outside, leaving, of course, 5 in the radical. Here, I'm going to take the square root of 4, which is 2. And there's nothing I can do with this. It's a prime factor. So in the beginning, it looks like I could do nothing with those radicals. However, I actually can do something with these radicals. I can simplify them by breaking them up into smaller values, smaller numbers, that is, and then taking the square root of the parts. Okay, so really, what do I have here? I've got 6 radical 5. And I've got 2 radical 5's and radical 9. Or I should say 9 radical 5's. All right, now I can combine these because they're all like terms. So I got 6 there, 2 there, that's 8. 8 plus 9, that's 17 radical 5s. And I'm done. All right, let's move on to the next one. Well, in the same spirit of working on our last problem, let's do this problem. So what's 4? Well, I actually could take the square root of that. And actually we could see that fairly immediately. Let me just actually circle this so you could see what I'm concentrating on. Oh yeah, by the way, that square root goes over the whole thing. It almost doesn't look like it's doing that, so I want to emphasize that. So we're taking the square root of 4, and then we're going to take the square root of 9, and we could even take the square root of 25. See, in the beginning, it looks like you can't do anything. See, these radicals are not alike. So the only thing you're left with is trying to seek, well, can at least we break these down and simplify them? And we can. So I could take the square root of 4. So what's the square root of 4? Well, it's 2. So the 2 comes out the outside of the radical with the 7. And of course that x that was there is going to stay there. Okay, I already have an 8 on the outside. Let's see, what's the square root of 9? Square root of 9 is 3. Okay, I've got a 2 here on the outside. I'm going to take the square root of 5. I'm sorry, square root of 25, which is 5. And there you have it. I've simplified the radicals. Well, I just have to multiply the things that are on the outside. So this is really 14 radical x. This is 24 radical x. And this is 10 radical x. And now I can combine these, just like I can an algebra problem. So I could take 14, I could subtract 24, and what is that? That's negative 10. And I've got negative 10 and positive 10. Wow, that's actually a strange problem. I've got no radical x's, right? Because 14 minus 24 is negative 10. Negative 10 and positive 10, they cancel. So really, I've got no radical x's, which really means I have nothing, right? Because 0 times anything is 0. So this one is strange. The problem actually negated itself, and I'm actually down to 0. So all of that canceled, so to speak. Kind of a strange problem. That doesn't often happen. Anyway, that's all there is to it. Just make sure you get like radicals before you combine radicals. All right, so make sure you go back, check out our lessons, check out our interactive quizzes and our instructional videos. Take care.